Here we have a little wave demonstrator machine, and hopefully you'll be able to see this fairly decently, but what I'm going to do is I'm going to make some waves on this and show you some different wave interactions that are happening here. So first we'll start off with just a pulse so you can get a feel for what it looks like. So there, notice I send a trough and it comes back as a trough. And so the reflection here is a little different than the reflection that we saw when I demonstrated it yesterday. Yesterday, when my son was holding onto it, every time I sent a trough, you got a crest. Every time I sent a crest, it bounced back as a trough. It always came back inverted. But this time, it's coming back erect. It's coming back the same way. So if I send a crest, you'll notice that it bounces back as a crest again. And so you're saying, well, why is it different this time than it was yesterday? Why in the world is it bouncing back the same way instead of the opposite way? Well, the difference was last time my son was holding it down. And when my son was holding it down, that's called a closed end. And so when the end is closed, then we are going to get an inverted reflection. And when the end is open, we are going to get an erect reflection, and one that bounces back the same way. So I have a little clamp here, and I'm going to clamp down that end over here. So now that that end is clamped down, then again, if I send a trough this time, it will bounce back as a crest. And then on this end, it'll bounce back the same way as a crest. And so we find that at a closed end, we get that inverted reflection, and at an open end, we get an erect reflection, an upright reflection. So a crest stays a crest, or a trough stays a trough. But if we have a closed end, then we always get it inverted. A crest becomes a trough becomes a crest. When we create a standing wave, it's similar. And again, a standing wave is a wave with a regular repeating pattern. And this is only going to occur when we have interference. And so the waves going this way are going to mess with the waves coming back this way. And so when I start off with it, we don't see the pattern occurring until the waves start to come back to me. So here, of course, this is a node, a point of minimum movement, and this is an antinode, a point of maximum displacement. And so you'll see that we have nodes and antinodes that appear when I make a standing wave. And again, this is just a wave with a regular repeating pattern. And if I do it at a slower wavelength, again, I can find the right frequency that works here. But if I do it at a slower wavelength, then I get a bigger, a slower frequency, I get a bigger wavelength. And if I do it at a faster frequency, I'm going to get a smaller wavelength. But notice when I am making a standing wave here, what appears at the end. This is the important thing. Right now it's an open end, there's nothing clamping it down, and so what we find is we get an antinode that develops at the end. Again, if I make this a faster standing wave, if I have a higher frequency, I'm going to have a smaller wavelength, but you'll notice we still get that antinode at the end. Now if it's clamped down over here, if I put the clamp back on it, now it becomes a closed end instead of an open end. And when I have a closed end, then the only thing that can form there is going to be a node. And so when I do make a standing wave, once I get one developed, you'll notice that I get a node in several spots here, but we also get a node right at the end because it's clamped down. And so an open end will form an antinode, and a closed end will form a node. And that's an important concept to understand and remember. We also have that concept of interference. We said when we have waves that interact with each other, they're going to either have constructive interference or destructive interference. So what I'm going to do here is I'm going to send two troughs together, and you'll see in the middle that when they meet, they make a bigger trough. And so that bigger trough that gets met in the middle there was constructive interference, because two small ones made a bigger one. If I do the same thing with crests, notice that when the crests hit at the middle, they made a bigger crest, and the troughs made a bigger trough. That's constructive interference. On the other hand, if I send a crest one way and a trough the other way, you will find that we have destructive interference, and so they partially or completely cancel out. And so right in the middle where they hit each other, the middle one will not move very much. So notice right here, they go right through each other, but as they're going right through each other, what's happening is we get minimal displacement at that section where one was trying to pull up and the other was trying to pull down. So that was destructive interference. So that one did not move very much. Again, I'll show you that very quickly. So right there at the middle, we had very little movement, and so that's destructive interference. The crest and the trough tried to pull in opposite directions, and so we get that destructive interference that occurs. So we have constructive makes it bigger, destructive makes it smaller. And again, if we have a standing wave that develops, if we have an open end, we're going to form an antinode. And if I hold on to this and make a standing wave, then I'm going to form a node at the end. That's the only thing that I can form because it's not free to move. So a closed end will form a node, and open end will form an antinode. If I switch to a different medium here, what's going to happen is switching to a different medium, of course, means I now have a different speed. So notice that this is going much, much faster in this medium. And so the same thing happens again. If I make a standing wave and nothing's clamping it down, then I'm getting an antinode at the end. I have a node here. If it was clamped down, then it would be the same. It would be a node only if it was clamped down. Now, I am going to attach these two together, and if I put this little clamp on so that these are now connected, now we have energy that's going to move into a new medium. And if I move into the new medium, then it's of course going to transfer a little bit different than what we're thinking of. So here, when I'm going into the more dense medium into a less dense medium, what's going to happen is at the medium boundary, most of the energy is going to go into the new medium. And the energy that goes into the new medium will always be erect. If it comes in as a trough, it'll go through as a trough. If it comes in as a crest, it'll go in as a crest. It'll always be the same. But when we hit that medium boundary, since I'm going into a less dense medium, that seems like an open end to it. So first I'll let you see the transmitted portion. So I'll send a trough here, and you'll notice the trough goes there. You'll notice that since the trough goes much faster, the frequency that I set it at had to stay the same because it was the same frequency in here. But since I changed to a new speed, I had to have a bigger wavelength. Since I had a bigger speed, I had to have a bigger wavelength. And so here the trough was only about this big, and then here the trough stretched out to about that size when we did that. I'll try it again with a crest here. So we see a crest here, and then the crest becomes much bigger, much longer over here, because when it was going faster, it always also had to adjust to that longer. Now, if I set up a standing wave, again, what you'll see is that the wavelength over here is much shorter, and the wavelength over there is much bigger. But again, at the end, I don't know if you can see the end from there or not, but the end over there is an antinode because it's open. But in the faster medium, we're going to have that longer wavelength because, again, I'm controlling the frequency, and so that's what's happening there. But when we get here, again, the transmitted portion will always stay the same. It will stay erect. Either a crest will stay a crest or a trough will stay a trough. But this is the part that's difficult. I don't want you to follow it visually into the new medium. I want you to see that part of the energy is going to reflect back. Now, it's going to be a smaller amplitude because, again, what happens is the amplitude is a measure of the energy. Most of the energy is going that way, but a little bit of the energy comes back this way. But again, since I'm going into a less dense medium, that seems like an open end, and an open end always has an erect reflection. So if I send a trough here, what I want you to do is watch that comes back is a little tiny trough coming back. And so it comes back the same way that it came in. It's going to be erect like that. On the other hand, if I send the energy this direction, Again, if I send a trough, it will stay a trough over there. It will slow down and it will become a smaller wavelength when it comes there. But the energy, and again, this is going to be going really fast, so it's going to be hard to see. But I'm going to send a trough this way, but when it hits the more dense medium, that's going to act like a closed end to it. So the reflection is going to be inverted. So I'm going to send a trough back this way, and your eyes are going to want to look into that, but watch very quickly. You'll get a little tiny crest that's coming back this way. Did you see it? Try that one more time. Ready, set. Did you notice that it came back as a crest there? And so the energy that transfers is always erect, but the energy, if I'm going into the more dense medium, will come back inverted this way. It'll come back erect this way, depending on, again, which direction I'm going. So hopefully this makes a little bit more sense to you. When we make waves here, again, the open ends have a antinode that's forming. If I would clamp it down, then we would only be able to form a node at that point. And so the energy would show